Next section, okay, probability with fundamental counting principle, permutation, combination. Okay, so we do one at a time, probability with the permutation, and then later we do probability with the combination, and then we do factorial and so on. Okay, so one at a time. So one at a time right here, permutation. Okay, permutation. So I want to make this guy big so we are able to read this. Okay, probability with the permutation. Here, permutations. Okay, so I want to start with the probability permutations. Okay, permutations. All right. So let's have examples. The solution is given right here, but I don't want to read the solution. I want to read the story here. Okay, so let's read this together. We return to our concert tour with the U2, NSYNC, Aerosmith, and Rolling Stone. Okay, now 2 surviving members of Beatles joined. Okay, all right, so it's a 5 groups now. 5 groups now. There are U2, NSYNC, Aerosmith, Rolling Stone, and the survivor members of the Beatles. Okay. 5 groups tour agreed to determine order of performance, each band name written in 5 cards, okay, and so on. So here is, what is the probability of Rolling Stone form 4th and Beatles last? Okay, so our event here, okay, I want to point it out. This is our event. This is our event. Agree? This is our event. So probability of the event is event over total. Event over total. That's clear. So our event is number of ways to choose Rolling Stone 4th and Beatles last. That's our event. Total, no restriction. I just want to play all these 5 members. Okay. Are we okay with this? I want to play these 5 members. All right. So as you see, underneath, probability of Rolling Stone 4th, Beatles last. Number of ways to find Rolling Stone 4th and Beatles last. This is our event. Total numbers here. Total numbers here. So let me show you how to do with this event. Okay, one at a time. So as you see, no repetition. Is it clear? No repetition. I want to make it clear. No repetition. Order matters. Okay, so this is a permutation. We have practiced this from previous sections. Permutation. All right, so just keep in mind, in permutation, we have a couple of ways to do it. You make a number 9s, or we make a factorial, and so on and so forth. The easiest I said, we make a line. So I'm going to make 5 lines. Okay, 1, 2, 3, 4, 5 lines. The event says, okay, Rolling Stone 4th position and Beatles last position. So there are 5 groups, 2 groups already positioned, and remaining 3, we have to make an order. So there are 3 ways to choose the first guy, and then 2 ways to choose, and then there's only 1 way. This is the event. Are we okay with this? This is the event. But total, no restriction. So we still have a 1, 2, 3, 4, 5, no restriction. There are 5 members. So there are 5 ways to choose first one, 4 ways to choose the second, 3, 2, and 1. This is the total way. Okay, this is total way. So when you compute this, 6 over 120, and you reduce this, this is a 1. Is it 1/20th? 6. 1/20th. Okay, that's what the bottom of this and the solution was explained. Are we okay with this? Event over total. Event over total. All right, event over total, event over total. So keep in mind, it is event over total. Okay, event over total. I want you to turn the next page. Okay, turn the next page. Let's try problem 114. So which is a continuation of what we just had. Okay, let's look at it. Okay, use information in given example, the previous example, to find the probability of U2 first, rolling stone fourth, and beaters last. Now U2 is positioned again. So this time I'm looking for the probability. Now the event is now U2 first, rolling stone fourth, and beaters last. Now you have changed the event. That is number of ways to choose U2 first, rolling stone fourth, and the beaters last, all over total. Okay, no restriction. So let's do it. Again, I put the number line 1, 2, 3, 4, 5. U2 positioned, rolling stone fourth, beaters last. So we have two remaining the groups. They are Aerosmith and I don't know what are they, something like that. Okay, so there are two groups in one. This is the event. Total, no restriction. 1, 2, 3, 4, 5. There are 5, 4, 3, 2, 1. Remember, total, we have no restriction. Toss a coin 3 times, no restriction. We have 8 ways. Okay, so compute this. 2 over 120. This is 1 over 60. Probability. Probability. All right. So it's a little bit of work, but I want you to try first, okay? I want you to try first. Problem 115, problem 115, and see how much you can do. And let's do it together. So we try first, and let's see how we can do. Okay, so let's do this together. So let's try, see how much you have done. 7 groups, A, B, C, D, E, F, and G, okay? And order matters right here. Order of preference matters, okay? Probability right here. Probability of selecting D first. So our event is D first. So I want to say, okay, event D first over total. Okay, so let's see. 7 groups. 1, 2, 3, 4, 5, 6, 7. Okay, event D first, right here. D is here. So D positioned. There are 6 groups left. 6, 5, 4, 3, 2, 1. You can do this if it is a permutation. Order matters, okay? Order matters. Total. 7 groups. No restriction. 7, 6, 5, 4, 3, 2, 1. So it is 6, 5, 4, 3, 2, 1, 6 factorial over 7 factorial, 1/7. You can simplify that. Question? No question. Okay. Let's look at number 2, probability E6 and B last. Okay. So let's see. E6, B last. 1, 2, 3, 4, 5, 6, 7. E is here. B is here. No restriction on others. This is event. What's the total? 2, 3, 4, 5, 6, 7. Still no restriction. Agree? So we are writing 5 times 4 times 3 times 2 times, this is 5 factorial over 7 factorial. We compute this 1 over 42. Okay. Or if you think as this is a fraction, let me show you another way. So 5 and 5 canceled, 4 and 4 canceled, 3 and 3 canceled, 2 and 2, 1 and 1, so 7, 6, so 142. That's another way to do it. Same as the previous one. Okay, all this canceled out. So you have a 7 left. That's another way to do this problem. All right, are you guys okay with this? Event over total. No matter what, if you are looking at the probability, event over total. Okay, let's look at the number 3. Probability of event in order of, okay, restriction in here. So again, I want to make it, so permutation 1, 2, 3, 4, 5, 6, 7. D, C, D, B, A, G, F, E, okay, over total. Okay. There's only one way to have this order. Total is a 7 factorial. Okay, what's a 7 factorial? Okay, 50, 40, so I write it. Okay. Any questions so far? No question. So look at the last one. All right, probability of F or G performed first. Okay, so, okay, same thing. 1, 2, 3, 4, 5, 6, 7. Here is F or G. Okay, F or G. So if I put F here, so for example, if I put F here, then G has to be somewhere here. Agree? G has to be somewhere here. Somewhere you have a G here. If I pick, instead of F, if I pick G, then F has to be somewhere here. You know what I mean? So go back to here. I can have, but I can have 2 choices. It's either F or G. So I have 2 choices here, F or G. If I pick F here, G has to be remaining spot. If I pick G first, and F has to be remaining spot. So there are 6 ways to do it. 5, 4, 3, 2, 1. Over total. 7, 6, 5, 4, 3, 2, 1 total. So 6, 6, 5, 5, 4, 4, 3, 3, 2, 2, 2, 7. Any question? So this is probability with permutation. So I want to remind you one thing. These bar thing right here, you can make a bar like 1, 2, 3, 4, 5, 6, 7, and then here are bars and like this. Only if, okay, I want to make it clear, only if it is order matters, okay? It's only for permutation. Combination, you cannot do that because order does not matter, so you have to make it move around, so you can't make it, okay? Only if it is a permutation. How do I know it's permutation? Order matters, okay? All this, order matters. Okay, if order matters, okay, you use the bar like this, okay? So things like that. nPr or bit Order matters. The next page, order does not matter. Okay.